Alrighty, guys, we are going to do this hypothesis and variables practice. So we are going to be looking at a research question, a testable question, and identify the independent, dependent variables, write a hypothesis, and then we are going to pick one of these questions and then carry it out all the way through designing an experiment, okay? All right, so our first question is, will a ball roll farther on a wood or tile surface? What is it that we are purposely going to change here? Is going to be the type of surface. You'll notice this time the independent variable is at the end of the sentence. So it doesn't necessarily have to be that your independent variable is the very first thing you come across in your testable question. It could be at the end. All you have to do is think about what is it that we're changing, okay? All right, so then we're going to look at what is it that we're going to measure? What is our dependent variable? So we're wondering how far the ball is going to roll. So that indeed is distance. Okay, so our independent variable is type of surface. Our dependent variable is distance the ball rolls. All right, so remember when we write a hypothesis, we have to choose a side. So what do we have here? Here's one side and here's the other side. So I chose the tile as the side I was going to write my hypothesis with. Okay, so the hypothesis is if the ball rolls on the tile surface, then it will roll farther. Because remember, with our then it's going to address the dependent variable. It's what we think is going to happen. And it needs to address what the question is asking. We're not wondering how fast it's going to go. We're not wondering how straight it's going to go. We're wondering how far it's going to go. So if the ball rolls on the tile surface, then it will roll farther. And then because, now this is our why, right? Because the surface is smooth, causing less resistance. All right, now with a hypothesis, it could be proven true or not true. All right, so it's just what we think before we actually do the experiment, okay? All right, so let's take a look at our second research question. And this is the one that we are actually going to carry all the way through to designing an experiment. Okay, so will plant growth be affected by the type of light used, like sunlight and house lamp? All right, so let's take a look at what is purposely changed. What is our independent variable? Well, what our independent variable is going to be the type of light. All right, and here are the examples that we're going to have. That's going to be our choices. So what are we going to measure then? And that will be plant growth. Plant growth. So you see that the independent variable is type of light, and what we're going to measure then, our dependent variable, is the plant growth. All right, so we need to write a hypothesis, and we have to choose a side. So here's one side, and here's the other side. So am I going to write my hypothesis based on the plant being in sunlight, or am I going to write my hypothesis based on my plant being under a house lamp? You're going to have to choose which one you want to do of those two, and then what you think is going to happen with the plant growth, okay? All right, so I chose sunlight. So here's my hypothesis. If the plant is placed in sunlight, then it will grow taller because plants need sunlight for photosynthesis. All right, so I chose and defended the sunlight. Now, once again, may or may not be true. Okay, the hypothesis may or may not be proven true at the end of your experiment. All right, so let's take a look at this third and final research question and pick out the independent and dependent and write a hypothesis from there. When sticky candy is eaten frequently, do more cavities develop? Alrighty, so what are we purposely changing? And that is the frequency that we're eating this sticky candy. And what are we going to measure then? And that would be the number of cavities. All right, so frequency of eating sticky candy is our independent variable. And then what we're going to measure would be the number of cavities. So what are my two choices? I don't necessarily see it per se in here like I could on these, but when we're talking about something like this, we're going to think of the words less or more. So is sticky candy eaten less frequency, or is sticky candy eaten more frequency? frequently. So we're going to have to pick one of those two sides and then address what we think is going to happen with cavities, okay? All right, so I picked them more frequently. So my hypothesis is if sticky candy is eaten more frequently, then more cavities will develop, all right? I addressed the number of cavities because sugar causes cavities, all right? So you are able to pick up your independent and dependent variable from your testable question. And when you write your hypothesis, your if is your independent variable, your then is your dependent variable, and your because is your why. You know, you've done a little bit of research because we know a hypothesis is an educated guess. All right. So you do need to kind of do a little bit of research on the topic if you don't know anything about a wood or tile floor or sunlight and what kind of light a lamp might give or how cavities develop. Okay. All right. So I made this sheet here to go with the experimental design because we want to take it one step further. And the next step in the scientific method after writing a hypothesis is to design an experiment. All right, so I chose the one about the plant growth. All right, so our testable question is, will plant growth be affected by the type of light used like sunlight or in house lamp? All right, so we already identified our independent variable being the type of light, one of these two, right? And then our dependent variable is going to be plant growth. All right, we've already done that from this research question up here. Okay, so we have spent a decent amount of time looking at then what has to be the same. What has to be the same? We have to have a control. We have to have a experimental group, and then we have to have a control group. All right, so we need to have two different groups going on here. So what do we have to keep the same? We have to, this is just my list. You might be able to think of more than this. All right, so we have to start out with the same type and the same size of plant. So we can't have one that's just in seed and then one that's already has started to grow out of the soil. That's not fair. So we have to have the same type of plant and the same size of plant. We need to put it in the same size container or pot. We need to use the same amount type and amount of soil. We need to have the same type and amount of water. We're going to have the same length of light exposure. So what I mean by that would be like we can't leave one in the sunlight for like 8 hours and then leave the other plant under the lamp light for 24 hours. Okay, so you as a scientist would decide, well, what do I want that time to be? And we put that time in our experiment design. Okay. All right. So, but right now we're just thinking about all the control variables. So we need to be looking at it at the same growing time. So we need to decide as a scientist, how long do we want that growing time to be? What do we want that to look like? Do we want to measure after 4 weeks, after 6 weeks, after 8 weeks, after 12 weeks? You as a scientist would design that. Okay. The same location throughout the experiment. So you're going to use the same windowsill, and you're going to use the same location in a room underneath just a regular house lamp that you might have. You're not changing things up with location because then that would be changing a variable and you can't do that. All right, and you're going to use the same measuring tool that you to measure the height, okay? All right, so same. So what I didn't say in here that we have talked about is fertilizer. So you would fertilize them the same if you choose to fertilize this plant, the same amount and the same type of fertilizer, okay? So everything's the same except for where you're going to put these two plants, okay? All right, so now we're on to something that's new for us, where we are looking at designing an experiment. So we're going to start out by, we're going to plant. So when you design your experiment and you write out your procedure like this, you need to be very detailed. Another scientist needs to be able to look at what you've written down and figure out what it is you're trying to say, okay? All right, so we're going to plant 2 identical size plants with identical pots, and soil. Okay, so I need to add in here 2 identical size plants and type. All right, I missed that detail when I was first typing this in. So 2 identical size plants and type of plants with identical pots and soil. Everything the same size pot, same amount of soil. Okay, we're going to label one pot A and we're going to label one pot B. Okay, it's always good to label your groups A, B, C, 1, 2, 3, so that when you go to record your data, you would put the information for A, the one that's in the sunlight, for example, under the A column, and the lamp under the B column. It's just easier than writing a sunlight or table lamp every time. Okay, so you're going to put pot A in the windowsill with direct sunlight and pot B under a table lamp in a room away from direct sunlight, because we really want to know the effect of that table lamp. So we don't want that plant that's getting the table lamp also to get some direct sunlight. All right, so you're going to kind of put it away from a window, whether that be in a closet or someplace that is not receiving a lot of direct sunlight. Okay, so you have 2 specific locations. So you're going to you're going to expose both pots to 12 hours of light. So you as a scientist are going to design how long do we want this to be. All right, so clearly this experiment needs to be done in more of the summer months where we do indeed have 12 hours of daylight. In the winter time when it gets a little bit darker earlier in the day, we wouldn't be able to do this experiment. Either that, or we would have to change the number of hours, maybe down to something like 8 or 6. All right, so you're going to have the same amount, right? So you're going to have to go in and shut that light off, or take that plant out of the windowsill, or close the blinds, so that indeed 12 hours of sunlight with both types of sun, with both types of light. Okay, so then we're going to measure the plant growth every week. All right, so how often are you going in there? So you're going to go once a week. Okay, you're going to water the plants 50 milliliters of tap water every week during the measuring day. All right, so this is where we have talked about the amount and type of water each plant's going to receive. We're going to monitor plant growth for 8 weeks, and you as a scientist would design how long you want that to be. 12 weeks, 14 weeks, 6 weeks, 8 weeks, okay? And record data on data charts. And then data is going to include the date. So every time you come in and do an observation and a measurement, you are going to have the date. And so you would have something like 9-2. And this would be in a data chart. You would have plant A and B, and it would be in some type of chart like so. And maybe this is 7 centimeters, and maybe this is 5.5 centimeters. And then you come the following week, and maybe your plant is now 10.5 centimeters, and this is 9.2 centimeters. Okay, all right, so on and on you go for 8 weeks in this data chart, analyzing or collecting all your data. Then at the end, when you're all finished with it, you would analyze your data, look at it, see what kind of numbers you end up with, and decide, does one do better? Is plant growth affected by the type of sunlight, whether that be sunlight or a lamp, so the type of light. So you would figure that out by looking at all your data over once a week over the course of the 8 weeks that you are doing this experiment. Okay, all righty. So reach out if you have any questions, and make sure that you are getting all of this written in, all the extra little things I have written in. Pause this video as needed. Go back and watch parts again if you didn't catch it. All right, take care.